Hey everybody, hopefully yesterday's video helped you guys out a little bit in reviewing place value. Today we're going over multiplication strategies. If you have your packet or the soft copies, we're on this page right here. Alright, and then for those of you who are doing this on Study Island, you're going down to the assignment that was listed as multiplication. The problems we're going to be going over today are problems 1, 3, and 9, and then we're also going to be reviewing before that the different strategies we've learned on how to solve multiplication problems. Alright, so this part right here is we're just going to review the different strategies that we learned at the beginning of the year on how to solve multiplication problems. The first strategy is arrays. This strategy works best when we're doing 1-digit times 1-digit solutions. It can work when we're doing 2-digit, but you're going to be drawing a whole lot of circles or triangles, whatever symbol you want to use in order to solve them. So first things first, just to review what an array is. It's a set that is showing an equal group of numbers and rows. So when we go to solve a problem using an array, we're making columns and we're using rows. So in this example right here, our equation here is 3 times 2, so we set up 3 columns, and we have 2 rows, and there has to be equal number of units in each column and each row. So when you draw it out, 3 columns by 2 rows, you end up with a total of 6 squares. Same over here. If we're multiplying anything by 1, then the number of rows we're going to have is going to be 1. So here, 7 columns across the top, we only have 1 row. If you count the number of circles we end up in total, it's 7. Now, with some numbers like 20, there's going to be more ways to solve. So in this multiplication sentence here, 4 times 5 equals 20. Our product is 20. We know if you go back to looking at fact families, there's multiple ways we can get to 20. So we could do 4 times 5, 4 rows by 5 columns. Another way could be 10 times 2. We could have 10 columns, 2 rows. One of the best examples, I think, of maybe quickly looking at fact families and how it can do for different arrays is think of the number 12. So if my product of a number sentence is going to be 12, what are some different ways we can get to that? I'm going to go ahead, if you guys want to pause the video real quick, think of at least 3 different ways you can show 12. Okay, so if we look here, we have 3 different ways we can arrive at 12. So the first one, I have 3 rows by 4 columns, total of 12. 2 rows by 6 columns, total of 12. And here, 1 row by 12 columns, total of 12. So that's the nice thing about arrays, is you can find different ways to arrive at the same product. But again, if you want to get into higher digits, you're probably not going to want to solve using an array just because it would take so much longer to draw out all these shapes. So the next ones we're going to go over, we're going to kind of look at all 3 together because they all kind of flow naturally into one another. So when we are moving into 2-digit times 2-digit multiplication, I know a lot of us, we did best with area model and we kind of stuck with that, but we're going to kind of look over it again today to see how it naturally flows from area model to partial product and then finally solving standard algorithm, because this is what we want to be doing into 5th, 6th grade. So if you looked at that first problem on that first page, it is 18 times 12. What does that equal? So when we look at the area model we use because we are solving for area. And we know area is length times width. So when we draw out our area model, we are just drawing a large rectangle where we are solving length times width. The most important thing to do when you're solving for area model is to separate your numbers into their place value. So on each number, we separated it into tens and ones. So when we look at 18, we can pull out 10 and 8. When we look at 12, we can pull out 10 and 2. Okay? The most important thing to remember here is, and I know this is where some of us lose our confusion, is the digit is 1, but it is in the tens place. Okay? So the value of this one is 10. It is not 1. Once we pull out our tens and ones, then we go ahead and place them on our area model. So on the left side, I'm sticking with this left side, here's 10 and 8. Over here, 10 and 2. And what we're doing is we are solving for each individual area. So here I have 10 times 10, 8 times 10, 10 times 2, 8 times 2. Okay, once you solve each one, then you need to add it together because our end goal is to solve for the total area, not the individual areas. So if you look down here, where we solve for each individual square, and our total is 216. Now, starting at area model is great because it is so much easier to do these simple numbers together than it is moving straight to standard algorithm. That's why we like to teach this one first. Now moving on to partial product, okay, same thing, okay. All we're really doing here is we're getting rid of our square. We are still solving pretty much one box at a time, except these boxes are now being given place values. So if we look here, the first step that we solved here, I went ahead and color coordinated it. Hopefully this will make things seem a little easier and make it make more sense when we're trying to relate it back to area model. So we always start with the bottom number when we're doing multiplication, right? Bottom right number, so the ones place. We're multiplying our ones place times our ones place. You can see right here, ones times ones. Okay, and 2 times 8 is 16. We're not carrying it over up to the top like we normally would because we're doing partial product, which means each time we're multiplying numbers, it's its own individual product. We're doing it each part at a time. So if we look here at the area model where we multiply the ones place times the ones place, okay, it's the same exact thing. All right, and then we're going ones place times tens place. And then finally we're moving into the tens place on our bottom number, tens place times ones place, tens place times tens place. Now, I put down here to keep in mind that these ones right here, they're ones, but the value of them is not 1, 1, because we're in the tens place. The value of this one is 10. It is 1, 10. So once you get each partial product put together, you add it up. Again, 216. So this is just like a nice little way to go from simple, which is area model. Now it's looking more like it'll look when we solve standard algorithm, but we're still only solving one part at a time, the same way we did here. Now we get into standard algorithm. So when we go to solve for standard algorithm, it is the same thing we did for partial product. We are starting with our bottom number in the ones place. So you can see here that I draw a place value chart always. Why? Because I think it simplifies things. It helps remind us that when we're in the ones, it only has a value of 1. When we're in the tens, it now has a value of 10. So going into standard algorithm, okay, the first things first, ones times the ones, okay. This time, since we're not doing partial product, each one on its own, we do carry the 1. So 2 times 8 is 16. Here's a 6. We carried the 1. Go back. We are doing ones times 10 now. So 2 times 1, 10. we're in the 10, so we can go ahead and just leave that as it is. 2 times 1 is 2, plus the 1 we carried over is 3. Now, this is where I see most mistakes happening when we're going into standard algorithm. When we move on and we start multiplying from the tens place, we must start recording our answers in the tens place. Oftentimes I see us putting our answer here, and while we're doing the actual multiplication right, our answer is off because we're starting our answer in the ones place. So here 1 times 8 is 8, 1 times 1 is 1. So you go ahead and add that up, you get the 216. What might be helpful for those of you, if we're going to be at home for a while, if you just go ahead and if you can take a picture of this, or even just freeze frame it on this and write this out for you, you can have your own little anchor chart at home to help you with all multiplication problems coming up. So we pretty much already solved this. Looking at here, they're obviously using area model. Here, right here is our 10 squares. 10 square, here we have 8, so they obviously separated this 10 and 8, 10 and 2. And just like we did in the area model, you are just multiplying for each individual area, length times width, and you find your product here, add them together. So when we look at number 3, it tells us we are solving using arrays. Okay, so this goes back to there are several different ways to end up with the same product. Product, we know, is the answer to a multiplication sentence when we use arrays. So here, same thing as last time. These are what we like to call fact families, right? Different ways to end up at the same product. So for number 9, this is actually a 2-digit problem times a 1-digit problem, but we could still solve it using area model. So this one is, which of the following is equal to 53 times 4? When we go ahead and look at our answer choices, it kind of looks like what it looked like when we are separating our tens and ones place when we're solving using area model. So this tells me I can go ahead and solve using area model here. So 53 times 4, okay, go ahead and separate that out, tens and ones. So this is 50, and this becomes 3, and this is just 4. So if we drew this out into an area model, I would have 50, I would have 3, and I would have 4. So instead of having 4 squares like we did when we had a 2-digit times a 2-digit problem, it's just going to be divided into 2 separate areas that I need to find the product for. So right here, this is 50 times 4, and this is 3 times 4. So just looking at here, which of these looks like how we went to solve it? And again, this is where we go back into our problem solving skills, where we are process of elimination. This here says 3 plus 4, so that obviously can't be right. We are not adding 3 and 4 anywhere. Here I have 3 times 4, that can be checked off. 50 times 4, that can be checked off. So I just put a little mark here. That's a possible answer choice. Move down, 3 times 4. Yeah, that's right. 25 times 4. Well, nowhere here do I have the number 25, so I can eliminate that. Here I have 50 times 3. Well, no, because it is 50 times 4, and I have 50 times 4. I can eliminate that answer choice. So my answer choice would be B. Thank you guys again for tuning in and watching. We really hope that these videos are helping If at any point during one of the lessons that we're doing, there's a spot where you're not understanding, or parents, if you see your scholars kind of struggling as they're doing the lesson, please just reach out and let us know. And we can do like more individualized lessons for your child if you can let us know where they're having problems. Again, making a simple anchor chart like this, if you just want to take a screenshot of it and have it, I think it might be really helpful. We had them hanging up in our class all year. The end goal is to get our scholars from being here, being able to solve it using area model, and we're really pushing to so that they can get here to the standard algorithm. Hope you guys are staying safe and healthy. Again, if you ever need us, please just reach out to us, email, Blooms, or even message us here on YouTube. Those of you on Study Island, you can use that to message as well. Hope you guys have a good day, and we will be back tomorrow with a new lesson.